Hello friends, how are you? I hope you are well. Today in this video, I am going to explain modern periodic law with modern periodic table. In my previous video, I explained Mendeley's periodic table along with its merits and demerits. So today, I shall explain modern periodic table along with modern periodic law. So I hope children you might have subscribed. If you have not done, you do it immediately. As a result, you can get our lesson continuously. As a result, it will be smooth for your study and it will be easy to understand the entire topic consistently. So let us start. What is modern periodic law? First we start from modern periodic law. In fact, Mendeleev prepared his periodic table on the basis of increasing of the atomic masses. But afterwards, mostly on his analysis by X-ray, found that atomic number is more fundamental than atomic mass. Atomic number more fundamental than atomic mass. So, on the basis of this observation, a periodic table was prepared by Niels Bohr. And the law associated with that periodic table we studied by the name of modern periodic law. The law is that the physical and chemical properties of elements are the periodic function of their atomic numbers. It means if the elements are arranged according to the increasing order of their atomic numbers, their properties are repeated periodically. I have mentioned the physical and chemical properties of elements are the periodic function. Periodic function means the repetition of the properties at regular intervals. Okay, you can say that gradation in their properties. The gradation in the sense whether increase in properties or decrease in properties, but it repeat after regular intervals. We say that is periodicity. So, if the elements in a periodic table are arranged according to the increasing order of their atomic numbers, their properties repeat after regular intervals. That is called the periodicity. Repeatance of the properties at regular intervals. So, repeat means it may be either increase or decrease in their properties, variation, but it should repeat after regular intervals. So, it is better we will go through one example. For example, I am taking some elements to explain the periodic law, not the periodic table. Before that, we should know what is this periodic law. For example, I am taking lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I have taken these elements lithium, beryllium, boron to neon. Similarly, I can take that sodium, magnesium, aluminium, silicon, phosphorus, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. See that? I written some elements that too also according to increasing order of their atomic numbers. You know that atomic number of lithium is 3, 4, 5, 6, 7, 8, 9, 10. Again here sodium 11, 12, 13, 14, 15, 16, 17, 18. If I write its electronic configuration in its cells or in orbit, lithium I can write 2, 1, beryllium 2, 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, fluorine 2, 7, neon 2, 8. I have 10. These are the electrons in the cells. Similarly, in sodium I can say this is 281, 282, 283, 284, 285, 286, 287, 288. See that? Here I started from lithium, which atomic number is 3. So its electronic configuration is 2, 1. That means it contains one valence electron. That means the electron present in its valence cell or outermost cell. Beryllium, if you move from lithium to neon, number of valence electrons are increasing. Here 1, 2, 3, 4, 5, 6, 7, 8. Similarly, if I move from sodium, here also valence electron is 1. Here atomic number is 11, number of orbits 3. All those elements are written here, they contain 3 cells. But number of electrons in the outermost cell from left to right increasing. Here is 1, here is 2, 3, 4 like this way. So, in modern period table, elements are arranged in such a manner, however, their properties will be repeated after regular intervals. You see that here, those are present in this vertical column. All contain one electron as a valence electron. We know that the properties of the element depends upon the valence electron. Here valence electron, outermost orbit electron 8. Here is also 8, means they have similar properties. So I can say that their electronic configuration repeated after regular intervals. How the 2, 2 here also 2, 8, 2. That means electronic configuration is repeated periodically after regular intervals, because I said that properties of element depends upon the valence electron. So the valence electrons here repeated periodically, so it shows the periodicity. The valence electron related to electronic configuration. So here it shows the periodicity in the electronic configuration. This is the speciality of the modern periodic table. Its atomic number correspond to electronic configuration. So just I wrote modern periodic table law. The properties of elements are the periodic function of the atomic numbers. I can say the properties of elements are also periodic functions of their electronic configurations. This is the speciality of the modern periodic law. This is the explanation again regarding modern periodic law. Based on this law, a periodic table was proposed by or prepared by Niels Bohr. So, according to him, when he arranged the elements, he arranged it in according to the increasing order of their atomic numbers in horizontal rows. That means in this table elements are written according to the increasing order of their atomic numbers. Previously Mendeleev table atomic mass, but here he made correction. He arranged the elements according to increasing order of their atomic numbers. So in this periodic table there are 7 periods are there. We are discussing about the periods. Here elements are arranged in periods as well as groups. These horizontal rows are called the periods. Horizontal, that is the periods. Vertical columns, they are called the groups. So I am explaining what is about the periods. So there are 7 periods are there. You see that I mentioned here 1, 2, 3, 4, 5, 6, 7 periods are there. 1, 2, 3, 4, 5, 6 up to 18 vertical columns are there. They are called the groups. So let us discuss how the elements are arranged in periods. So the first period contains 2 elements. One is hydrogen, I have written. Last I have written helium. Hydrogen is there, helium is there. You know atomic number of hydrogen is 1, atomic number of helium is 2. That means the number of main cells, or you can say orbits, decides to which period the element belongs. See that the number of orbits, the number of orbits decide to which period the element belongs. Number of main cells or orbits or cells decides to which period it belongs. For example, you see that hydrogen and helium. Hydrogen contain 1 orbit. Helium also contain 1 orbit. So those elements having only 1 orbit, they belongs to first period number 1. So their cell number, main cell number represents the period. This electronic configuration, I can write this is 1s1, 1s2. That means in a period, how many elements, the number of elements in a period, it depends how electrons are filled in various cells. See that? How elements are filled in various cells. It will decide the number of elements. It will be decided how the elements are filled in various cells. So first period contains 2 elements because first cell means K cell, its capacity only 2. Here the electronic configuration I wrote hydrogen and helium. I can write that 1s1, 1s2. So in this period, those elements are there. Their electronic configuration can be written in 2 ways. One is 1s1, one is 1s2. 2 two ways. There are two electrons, or you can say that first period contains the element those having only one cell. First cell capacity is 2. That's why 2 electrons can be accommodated in the first period. Let us see the second period. Our first period is called very short period. First period called very short period. Second period short period. Third period also short period. Fourth period long period. Fifth period also long period. Sixth very long. Seventh also very long periods. You see that second period, how many elements are there? Second periods, you observe that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Total 8 elements are there. Every period starts with a new cell. For example, elements belongs to second period starts with the second cell. See that lithium. So lithium atomic number is 3. So we write 2, 1. In the first period, only one orbit there. But in the second period, second orbit started. So every period starts with the new cell. This one first cell, here second cell introduced, here third cell introduced, here fourth cell introduced, here fifth cell introduced. Okay. So in the second period, those elements are there. Their electronic configuration may be between 2s1, 1s2, 2s1, 2s2, 2p. See here written neon. Neon means atomic number 10. 10 means, see, I can write better 2, 8 means maximum electron in one of these cell is 8. So it contains 8 elements. If I write the electronic configuration of a neon in the form of subcells, here you see that this is the second period. Second period, that means its subcell 2s, 2p. Here S capacity is 2, P capacity is 6. This 2 plus 6 is equal to 8. That means the second period contains only 8 elements. For CBSE students, for you, subcell S and P is not explained. That's why I said that maximum number of electron in any of the cells will decide the number of elements in that period. So since it is the second cell matter, second cell, first cell is 2, second cell is 8, so it contains 8 elements. If I consider the third period, let us see. Third period also same thing happen. Third period, it starts with the one more new cell, that is the third cell, no doubt at all. Okay. but the number of electrons in the number of elements in the third period is 8. What is the reason? The reason is that 3s, 3p, after 3p we don't write 3d, we write 4s. So in the third period the subcell 3s, 3p will be filled. After that 4s, that means this is the matter of a fourth cell, will go to the next period. So 3s to 3p 6, that means this 2 plus 6, 8. That's why third period also contains 8 elements. Let us go to the fourth period. So first period 2 elements, second period 8 elements, this is 2, so this is 8. Third period also we found 8 elements. We'll see the fourth period. Fourth period, you see that starts from potassium up to the krypton. Okay? So here total 18 elements are there. How 18 elements are there? So you see that 4s is there. How we write electronic configuration? 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay, again 4p. See here S capacity is 2, D capacity is 10, P capacity is 6. After 4p, here 2, 10, 6. 2 plus 10, 12, 12 plus 6, 18. So fourth period contains 18 elements. So an element belongs to which period? It will be decided by the number of cells. Cell number will decide the which period. Cell number, it contains 4 cells. That means it is belongs to fourth period. At the same time, number of electrons in its outermost orbit will decide the group number. Now you see that suppose one element is there. Its atomic number is 14. I am not telling which element atomic number is 14. Already you know. Silicon. Okay. So which period it belongs? 2, 8, 6, 10, 2, 8, 4. That means it contains 3 cells. First cell K cell. This is the L cell. This is the N cell. That means total 3 cells are there. So definite it belongs to third period. So this is about the how the elements are arranged in period. Similar way, this one contains the 18. So first period 2, second 8, third 8, fourth 18, fifth also 18, sixth one 32. Sixth period contains 32 elements. See that here 18 is there, down the 14 is there. If you leave the lanthanum is here, lanthanum place is here. That means the next element onwards, cesium onwards, 14 elements are there. So 18 plus 14, 32. Okay, here those elements are there. They are called the lanthanides. It starts from the element lanthanum. You can consider lanthanum here. Okay, this series head by the element lanthanum, that is called the lanthanide series. its properties, all these elements having the similar properties. They have written separately because this place is not enough for them. It will not fit in this periodic table. That's why below this periodic table separately they have mentioned. One is the lanthanide series, one is the actinide series. Okay, so it is headed by the element actinium. You can say actinium is here. So leaving this actinium, still 14 elements are there. So 18 there plus 14 here, 32. That's why I said that fifth period is a very long period which contains 32 elements. Seventh period, still it contains now 32 elements. Okay, so this is about the how the elements are arranged in periods. Okay, next one we'll discuss about the groups. Groups means these are the vertical columns. Vertical columns. See that there are 18 vertical columns are there. I have written with Arabic numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 like that. Okay. Roman letter also you can mention. Earlier we used Roman letter. First A, second A, is third A, fourth A, fifth A, sixth A, seventh A, eighth A, third B, fourth B, fifth B, sixth B, seventh B, eighth, first, like that you can find. But I have mentioned here Arabic numbers 1 to 18, which is the latest. So I have mentioned only the Arabic numbers 1 to 18. 18 vertical columns, they are called 18 groups. So we'll discuss about these columns. The elements of a phosphate, they are called alkali metals. Alkali metals. Why they are called alkali metals? Because when they react with water, their nature is alkali, their basic nature. They are called the alkali metals. You see that except hydrogen, all having one valence electron, except hydrogen, all are here metals. Lithium, sodium, potassium, rubidium, cesium, francium, all are the metals. All contains valence electron 1. Their valency also 1. Okay, that means their electronic configuration is repeated down to down in a group. Second A, they are called alkaline earth metals. They are also basic in nature, but in comparison with the first A group elements, they are less alkali in nature. That's why they are alkaline. They are little less basic in nature than alkali. They are available in earth crust, so we say they are the alkaline earth metals. Okay. Now in your 10th class we discuss about the normal elements. Normal elements, or we can say representative elements. Which elements are the normal elements? First A group, second A group. Again, starts from 1, 2, 13, 14, 15, 16, 17. These are the normal elements or representative elements. Okay, we say these two elements are S block elements, and 13 to 17 these are P block elements. These normal elements are representative elements. They contains S block and P block. S block and P block means the last electron here enter into the S orbital, whereas the last electron here enter in the P orbitals. So we say S block and P block elements. So in this class we discuss about these normal elements. Okay. So first a alkali metals, second a alkaline earth metals. Now we'll see that, okay, the first A I have mentioned here the group 1, here group 2. Now we'll see the group 13. So group 13, it is headed by the element boron. So this is boron family. So family name is there. How the head of the family. Okay. So this family led by boron. All those elements are here. Their valency you will find 3. All having valency 3. Here those elements valency 1. Those elements here valency 2. Okay. So here valency 3, 4, 3, 2, 1. Like this one. Okay. So this is boron family. Next element is the 14th one. It is headed by carbon. We say that is the carbon family. Okay, carbon, silicon, germanium, all having the valency 4. Their electronic configurations repeated down to down. That means it shows the periodicity. Next one is the nitrogen family. So 15th one is the nitrogen family. Okay. 16th one is the oxygen or chalcogen we say. So 16th one, that is the oxygen family, or we say that is the chalcogen. Chalcogen in the sense they are the ore producing, like sulfur dioxide, like iron oxide. So we say they are the chalcogen family. Next to oxygen, it is headed by halogen groups. So the 17th one, we say that is the halogen family. Halo means this is the salt, gen means that is they are the producer, they are the salt producer. You see that, suppose sodium react with the chlorine, we get sodium chloride, common salt. So this family are called the halogen family. And the last group, last but not least, which one? That is the 18th group. That group name also we say they are the zero group elements. They are also zero group elements. So 18th one, they are the noble gases. Okay. So already you know that those are present in the right side of the periodic table, starting from helium, neon, argon, krypton, xenon, radon. Okay, uranium, actinium. All are the inert gases. Their outermost orbits are fulfilled. They are inert because they do not react with the others, or you can say they react rarely. They are available rarely. They are very less reactive, almost not reactive, but we found the compounds of xenon. In future what will happen we cannot say. So they are the inert gases because they are chemically inactive. They don't make reaction with the others because their outermost orbits are completed. So this is about the groups, and I said already this lanthanum and actinium, these two series, we say lanthanide series and actinide series, they are the 8 block elements. The elements those written 3rd to 12, they are called the D block elements. I said S and P block elements. S and P block elements, they are the representative representative elements. Their outermost orbits are incomplete, but the elements from 3 to 12, they are called the D block elements. There are two cells. One is the outer cell, another one is the penultimate cell. The next to the outer cell, means just before the outer cell. So outer cell and penultimate cell both are incomplete for D block elements. Okay, and those are written bottom of this period separately. I said lanthanides and actinides. They are these two are the A block elements. So their properties are similar. They are also said to be inert transition elements. These elements, D block elements, are also called the transition elements, are written transition elements. These are also belongs to them. That's why they are said to be inert transition. This is inert transition elements. Okay, in a periodic table, elements roughly divided into metals and non-metals. Generally, those are present in the left side, they are the metals. Those are right side, they are non-metals. Okay, you see the elements: boron, silicon, germanium, arsenic, antimony, tellurium, polonium. These elements, what are mentioned in the blue ink, they are the metalloids. That means some extent they show metallic nature, some extent they show non-metallic natures. So there belongs to the metalloids. Here to here, these are the non-metals. These are the inert gas elements. Here, those elements present in the first and second, they are the light metals. And those elements present between 3rd to 12 group, means starting from scandium up to the zinc, they belongs to transition metals. So children, this is about the modern periodic table. In my next video, I shall explain the gradation of our different properties of the elements, how it changes in a period and also in a group. I hope that you might have understood. So until the next video, till then, bye.